All right, so we're going to start with law of sines before getting into law of cosines, and I'm just going to go ahead and give you the actual formula. So the goal with law of sines is to find missing sides and angles. Same with law of cosines, but it's worth reminding you. So we'll be finding missing sides and angles in triangles. And this is used mostly when we have non-right triangles. So that's really the key in these 2 units, is we're going to have non-right triangles. So let's just kind of draw our generic triangle. It's going to look like this. You can pick your own generic triangle if you want, but this is what I always draw. And so then across from those angles, we have the lowercase letters for side lengths. The law of sines says that if I take sine of A, and then divide that by lowercase a, so the side length, this actually equals sine of B over its side length. So this ratio is equivalent. And then we could also say that this is equal to sine of C over lowercase c. So when you use this formula, you don't actually write all 3 out. You would only use part of it. So for example, let's say I wanted to just solve for A or something and I had C, I might do something like this. So you pick and choose which part of the formula to use. So it's sort of deceptive because there's 3 parts to this equation, but really we would just pick part of it. This just shows that all of those ratios are equivalent. Alternatively, sometimes it's good to use the reciprocal version. So we might use A over sine of A instead. So really this is the exact same formula, but there you go. So the 2 versions of the formula we have are this. Now, if you're kind of wondering where this comes from, that's a great question to ask. I will probably do a video later on kind of showing the proof, or maybe I'll give you guys a chance to work through the proof where this comes from, or the derivation, I guess I should call it, not proof. But for now, let's just take this as granted and we'll just use it in some problems. All right, so let's start off with an example. Let's say that I want you all to determine the value of any missing angles or side lengths. And here's the triangle. Now I never draw these to scale because I always just draw my generic triangle. So this side over here is going to be 85 degrees. This one's going to be 32 degrees. And then across from the 32, it's going to be 6, I'll call it inches. We'll start doing some units here. Okay, so here's our triangle. Now a good thing to start with, before you even start solving, you might see something immediately, but before you start doing anything, it's a good idea to label. So I'm going to label this one capital C, and this one lowercase c. You can use X's and Y's, you can use any sorts of letters you like. And then over here I'm going to label this A, just so that it kind of matches my generic triangle, which I have up here. All right, now there's a few different ways to start. We did just get this nice nifty formula we could use. Although before I do that, I might just use another fact about triangles. This is something that's probably a good check before you start a problem. The sum of all the angles has to equal 180 degrees in a triangle. So that means that 85 degrees plus 32 degrees plus whatever C is has to actually equal 180 degrees. So if we figure that out on the calculator, we could just do 180 minus both of those, 180 minus 85 minus 32, and I end up with C being it equals exactly 63 degrees. So I've actually already found one of my missing pieces. C is 63 degrees. And I don't actually have to use the law of sines to solve for that. Now for the next part, I need to figure out A or C. It doesn't really matter which one I use. So let's go ahead and solve for A first. And to do that, I'm going to have to use the law of sines. So I'm going to say A over sine of its angle, its corresponding angle, 85 degrees, equals... Now, I don't want to use C here because I don't know C. So I'm going to actually use this ratio because I do know it. Notice if I try to use C, I would have C over sine of 63. So I would have an equation with two unknowns in it. All right, so now I have my formula set up. I use the reciprocal version because it takes a little bit less work since A is already in the numerator, but it really doesn't matter which one you want to use. So solving for A, we're going to end up with 6 over sine of 32 degrees times sine of 85 degrees. So let's go ahead and plug that into the calculator. I didn't say how many decimals to round this to, so maybe we'll do, I don't know, 2 or 3. We'll see what happens. All right, so I got 11.279. Let's just do one decimal place. Excuse me. And make sure to include your units here. So it's about 11.3 inches. Just double check that. Okay, yep. All right, so that was for A. We just solved for A, sorry about that. Now we're going to solve for B, or sorry, C, lowercase c. At this point, it doesn't really matter what I use. I could use A or B since I now have the side length A. If you use A, though, you would have to use the unrounded version, which seems like a pain to have to write all those decimals down. So I'm just going to use B again. Excuse me. So we'll say B over sine, excuse me, C over sine of my angle was 63 equals B over sine of its angle. And so then solving for C, just like we did above, I would end up with 6 times sine of 63 divided by sine of 32, and I end up with about 10.1. Cool. So my triangle now is, I have A was 85, which was given. I got A is approximately 11.3 inches. B was 32 degrees, and I got, this was all given. And then C was 63 degrees. And C, the side C was about 10.1 inches. Okay. So there you have it. That's law of sines and actions to find the missing sides. I wrote all of them down here, so you have all of them. And that's good. All right, let's try another example while we're looking at this. Let's say in a triangle, we'll say that side A is, sorry, I don't want to do side A. Let's do side B again. 3 feet. Angle A is 14 degrees, and then angle C is 110 degrees. And then we need to find all missing angles and sides. Okay. So in this one, you're not actually given the diagram, you have to create it. So that's going to be the first step. Again, not drawn to scale. A is 14 degrees, C is 110 degrees, and then B is 3 feet. This is side A and side C. So at first glance, this seems like it might be impossible because we actually are not given any angle and side combo. However, we can solve for B right away because 110 plus 14 degrees plus B has to give me 180. So that means that B is going to end up being 56 degrees. And so now I could actually use law of sines to solve it. We would say you could do A over sine of 14 equals 3 over sine of 56, which would give you A. And then to solve for C, you'd go C over sine of 110 is the same as this ratio for B, 56 degrees, and then this would give you C. So let's go ahead and solve those real quick. 3 times sine of 14 divided by sine of 56. I got an incorrect answer. 3 times, oh, maybe I didn't. 3 times sine of 14 divided by sine of 56. I got a different answer that time. Okay, I'm getting about 0.875. And then for C, I'm going to end up with 3 times sine of 110 divided by sine of 56. So I get about 3.400 for C. Okay. All right, so this video is starting to get a bit long, so I'm going to end it there, and we'll do a couple more different sorts of examples with law of sines, just so you see some different ways to use it.